All right, so we're going to start a couple lessons on trig, and we're just going to review some things you should hopefully already know. So first of all, what's the first thing you think about with right triangles? In a right triangle, what's the relationship between the sides? And if this is A, B, C, hopefully you remember the Pythagorean theorem, because most people, that's one of the things they always remember. A squared plus B squared equals C squared. And the most important thing is that your hypotenuse is C. And we're going to take this and we're going to apply it to the trig. Okay, so the first thing that we want to talk about is in a trig ratio, the most important thing you have to identify is the angle. Notice here, the first thing I have to mark is the angle, because until you have the angle, you don't know anything about the sides. Now, the one thing you always know is the hypotenuse is always across from the right angle. But the important thing about marking the angle that we're talking about is the side across from the angle is the only one that can be the opposite. So you don't know which one's the opposite side until you mark the angle. And the angle next to the side next to the angle is the adjacent angle. So we use these three relationships to determine the ratios for sine, cosine, and tangent. All right, so if I were to take on a calculator sine of an angle, it will have the exact same value if I take the length of the opposite side and divide it by the hypotenuse. Cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And typically one of the things people remember from geometry, trig, is the phrase so, ka, toa. So is your sine, sine O over H, OH, ka, cosine A over H, AH, toa, tangent is O over A. So really it's just ratios of each of these trig functions. So SOHCAHTOA and the ratios. So what we do with that is if you're given the sides of a right triangle, the first thing you need to do is first find all three sides. All right, if you remember when I was talking about earlier, a squared plus b squared equals c squared. The only thing that really matters is the hypotenuse has to be the c squared. So we do a squared plus 18 squared equals 33 squared. All right, so 18 squared is 324. 33 squared is 1089. Then we subtract 324 from 1089, and a squared is 765. Square root both sides. Typically, I get picky when you take the square root. You should have plus or minus, but this is the length of a side, so it's always positive. But 765, if you do your square card, can be broken into 9 times 85. So let's think about square root of 9, square root of 85 is 3 square roots of 85. Because you can take the square root of 9 and get 3. You can't take the square root of 85, so it stays under the square root. So I'm going to bring this back up here and label that side. Now, they want us to find for angle B. So the next thing I'm going to do is mark the angle that they want me to find. And I go straight across from that angle. I'm going to label that the opposite. The hypotenuse is always across from the right angle, and the other side is the adjacent. So we want sine, cosine, and tangent of angle B. So what's really important is that you write sine B, cosine B. If you don't have the B, it's not right. It's really important that you include which angle you're talking about, because if it's a different angle, it's a different answer. So the B is really important. All right, so if we think about so, ka, toa, so for sine, opposite 18 over hypotenuse 33, and then both of these can be divided by 3, and the simplified answer is 6 over 11. For cosine, ka, ah, the adjacent is 3 square roots of 85 over h, the hypotenuse, is 33. Both can be divided by 3, square root of 85 over 11. Finally, tangent, toa, OA. O, the opposite side, is 18 over the adjacent side, 3 square roots of 85. Once again, they can both be divided by 3. Now, if you remember when we were doing radicals earlier this year, it's not considered to be in simplest form if the square root's in the bottom. I'm not always super picky about this, but if you were to take your ACTs, it might be in the bottom, but they might fix the square root by multiplying by the square root top and bottom. And so I want everybody to be aware of how to get this answer. I would be okay with either answer, but I want you to know how to get this one. If there's a square root, you can just multiply top and bottom by the square root. Then on the bottom, the square root goes away because it's kind of think of the square root of 85 times the square root of 85 is the square root squared. So it just cancels it out. Okay, so where you guys all learned about the basic 3 trig functions, there's 3 more, because in one of the things we have in math are reciprocals. So the reciprocal of sine is cosecant. Remember, if you're finding reciprocals, you just put 1 over. So think about the reciprocal of 3 is 1 over 3, 1/3. What do we do if it starts as a fraction? The reciprocal is just 3 over 2. Okay, so this is cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent reciprocal of tangent. So let's think about what is sine. Sine is, here, let me clear this a little. So, ka, toa, because these all relate to each other. If sine is O over H, what's the reciprocal? H over O. So if cosine is A over H, secant is H over A. Toa, tangent is O over A, cotangent A over O. So what I always recommend, write cosine theta equals, write these 3 this way and the reciprocals underneath, because then you can just flip them. So let me show you what I mean. So our first step is always to find all 3 sides. A squared plus B squared, we're missing C squared, that's our hypotenuse. And it doesn't matter which one's A or B, or C is our hypotenuse. So then I'm going to square. Then I'm going to add. Then I'm going to take the square root And then nothing can go into 149. So I'm just going to put the square root of 149 up top. And this is talking about angle P. So we mark angle P. Super important. The first thing you want to do once you know all three sides is mark the angle. Okay? Because you go across from the angle, that's the opposite. Go across from the hypotenuse, or the right angle, that's the hypotenuse. And the last one is the adjacent. Okay, so this time we're talking about P. So I'm going to write sine P equals cosine P equals tangent P equals. Then underneath sine P, I'm going to write its reciprocal, sine cosecant, cosine secant. This is the most annoying part of these problems, but once you have this filled in, it goes really quickly. Now, some people struggle with remembering the reciprocals. Tangent and cotangent are easy. Some people just remember that each one has a C. So if this is sine, this is cosecant. If this is cosine, it's secant. Tangent gets cotangent. Probably the best thing I've ever heard. Secant comes second. It's the second one. So if you always go sine, cosine, tangent, secant comes second. Cosecant, secant, cotangent. Okay, so let's just fill in. Sine, using so, ka, toa. Sine, opposite over hypotenuse. Opposite is 7 over hypotenuse. I'm kind of out of room, so I'm just going to leave this and that's fine. So the reciprocal of sine, I'm just going to take and flip it. So as soon as you have the three basic ones, just flip it for the reciprocals. Cosine, A over H, A, H. Then for the reciprocal, flip it. So whatever you put for sine, flip it for cosecant. Whatever you put for cosine, flip it for secant. Tangent, O over A. O is 7, A is 10. Flip it for the reciprocal. So really just getting set up to put the answers is the most annoying. I think once you have everything set up, it's pretty easy to fill in. All right, so the next thing we want to do is understand how to find these values on a calculator, because we're going to use these values to help us solve. So if you have a calculator, you want to get that out. If you don't have a calculator, just turn the calculator on your phone and turn it sideways, because you want to get to the trig stuff. Okay? And literally, usually on the phone, you push 18 and then push sign. Calculators can go either direction, but if you find sine of 18, and we're going to go to the nearest hundredth, 2 decimals, 0.31. It's 1 because we have to round it. Cosine 78, 0.21. Tangent of 110 is negative 2.75. And there is no cosecant button, not on the calculator, not on the phone. So we're going to use the relationship. We know cosecant is the reciprocal of sine. Cosecant of 50 is the same as 1 over sine of 50. So you're going to take 1 divided by the sine of 50, and you get 1.31. Another way you can do this, if you're struggling, you can find sine of 50, find this answer, and then if you push x to the negative 1, that's the reciprocal button. Try that and see if you couldn't get this answer this way, try it this way. Same thing with cotangent. It's just the basic 3 on your calculator. So to find the reciprocal functions, you're going to use 1 over tangent, which is 0.58. So these are just how to find certain values on your calculator. All right, our next step is using these relationships to find all different pieces of the triangle. Notice whenever it's capitalized, it's a degree, it's an angle measurement. This is telling me angle A is 46. Little b is always across from capital B. So I'm going to find B, come across, and this side length is 8. Angles are capitalized, sides are lowercase. Okay, how many degrees in a triangle? If I add up all the angles, there's always 180 degrees in a triangle. If there's a right angle, that means there's 90 degrees left for the other 2 angles. I mean, you could add 90 and then subtract from 180. I think it's easier just if this one's a right angle, take 90 minus 46 to get the other angle. If the directions say to solve the triangle, that means find all 3 angles, which we have, and all 3 sides, which we don't have. All right, so I have this angle here. Let's just go ahead and mark angle A. It doesn't matter which one you mark. I'm just going to use A. So for this angle, if I come across, this is my opposite, this is my adjacent, this is my hypotenuse. So if I want to find the opposite side and I know the adjacent side, so ka toa, which one uses OA? Notice that's tangent. So I'm going to take tangent of 46. It equals, let's not use O because that's going to look like a 0. I'm going to label this A. A is my opposite side over my adjacent side, which is 8. So now I have an equation. If A is being divided by 8, how do I get A by itself? Multiply both sides by 8. This cancels out. Then I can take 8 times tangent of 46. And A is 8.3. Now, this makes sense. Notice these 2 angles are just about the same. 46 is just a little bit bigger than 44. That means the side across, 8.3, is a little bit bigger than the side across from 44, 8. So that makes sense to me. All right, now we're going to find the hypotenuse. You don't want to use any approximated values. So what we're going to do is still use angle A. And this time, if I'm using angle A, I'm using the adjacent. And now I'm going to use the hypotenuse. Which one uses AH is cosine. So now I'm going to take cosine of 46. And that equals, my adjacent side is 8 divided by my hypotenuse. Let's call that C because that's across from big C. So that's going to be my little c. Now, I can't solve an equation with my variable in the denominator. So the first thing I'm going to do is multiply both sides by C. Then the C cancels. Now, if C is being multiplied times cosine 46, I'm now going to divide by cosine 46. What I always recommend when this variable is in the bottom, it just trades places. So see how we have C equals 8 divided by cosine 46. And if I plug this into my calculator, I get 11.5. So when you get done, you should always make sure that the sides make sense. The hypotenuse should be the biggest side, and then the other two angles, if this has the biggest angle, this should have the biggest side. Smallest angle, smallest side. That always has to work. All right, the last thing we're going to talk about is trig functions with a point. So we're going to be graphing the last part. And what we're going to do, we're going to graph a point somewhere on a graph. And you will always connect this point to the origin. So for points, the first thing you do is connect. You're going to create a triangle, connect the point to the origin and to the x-axis. These are the only two things you're going to connect it to. Origin, x-axis, every time. Now, the angle is always the angle connected to the origin. So think how this is your opposite side. When you connect the point straight down, creating a right angle, that means this is the hypotenuse and this is the adjacent. Well, let's think about this point. If I start at the origin and I graph a point, this is my x coordinate, this is my y coordinate. The adjacent is always x, the opposite is always y, and this actually relates to the unit circle. So I'm going to call this r for a radius. Okay, so this is probably going to be the most important thing I want you to write. We know sine is opposite over hypotenuse, but it can also be written as opposite is y over hypotenuse is r. Y over r. The reciprocal, hypotenuse over opposite, or r over y. Cosine is a over h, adjacent over hypotenuse, or x over r. Reciprocal, hypotenuse over adjacent, r over x. Tangent is opposite over adjacent, which is y over x. The reciprocal, adjacent over opposite, x over y. So if you're on a graph, it's sometimes easier to do x, y, and r. If it's just a plain right triangle, SOHCAHTOA works just fine. So maybe take a picture with your phone. This is probably one of the most important pages because it gives you both SOHCAHTOA with the reciprocal functions and x, y, and r. So let's apply this. All right, so I'm going to make a little triangle. Here, let me move that up a little bit. So I'm going to make my graph, and I'm going to graph +3, -4. That point is in the fourth quadrant. Sorry, with my slate, it's always crooked, so I apologize for that. You always connect it to the origin and to the x-axis. So the x is 3. The y, so we're going over 3, x is 3, y -4. Then we're going to do a squared plus b squared equals c squared. But do you remember the most common right triangle? 3, 4, 5. Now, if you need to use the Pythagorean theorem to find that, that's fine. But we have x, y, r. I'm going to move this one. Now, if you don't have an angle, what is typically used is theta, just a circle with a line through it. Sine theta equals cosine theta equals tangent theta equals. When it comes to trig, we always use Greek letters. Then I do my reciprocals, cosecant theta, secant theta, cotangent theta. Writing these out are the most annoying part because the answers are kind of easy. Now, here's my angle. It's always connected to the origin. If you're still struggling with, if you like SOHCAHTOA, it still works with this, but it's also good to understand the x, y, r. So opposite, or y, is -4 over the hypotenuse 5. Then just flip it for cosecant. Cosine is the adjacent 3, or x, over the hypotenuse. Flip it. Tangent is opposite over adjacent. Flip it for cotangent. And that's it. Okay. Graph your point. Label all your sides. Find the hypotenuse. Once you write out your 6 trig functions, it's just a matter of fill in the blank. All right. So let's just do one more. Oh, that was not what I wanted to do. Let's just do this one. I think that will give you enough information. So when I graph -5, 12, 1, 2, 3, 4, 5, I'm just going to kind of come up here and call this 12. So -5, 12. We always connect it to the, okay, I don't know if I can do this that big. The origin, and then straight down to the x-axis. Now, this is super sloppy. This should be straight, but you're always connecting to the x. Every single time connect to the x. That's also going to be extremely important for next week's lesson. All right, so now I'm going to label my sides. This is -5 for the x, 12 because I went up 12 for the y. And then if we have -5 squared is 25, plus 12 squared is 144. This is also a very common, to me, this is the second most common right triangle. 169 is c squared, and the square root of that is 13. This is a 5, 12, 13 triangle. My hypotenuse is here. This is my hypotenuse, x, y, r. So this is actually the angle that we're talking about, okay? So sine theta equals cosine theta equals tangent theta equals cosecant theta equals secant theta equals cotangent theta equals. Okay. All right. Then it's just a matter of filling in the blanks. Sine is the opposite, 12. And see, this is where I think it's helpful to know your x, y, and r. Sine is y over r, 12 over 13. Flip it. Cosine, -5 over 13. Flip it. Tangent, y over x, 12 over -5. Flip it. So if you know your sine, cosine, tangent, and you know which ones are the reciprocals, you don't have to memorize what they equal. Just put sine and cosecant next to each other, cosine and secant next to each other, tangent and cotangent next to each other, and just use the reciprocal relationships. Okay, and that's our lesson, our first trig lesson.